Hi everyone, welcome back to another video from my channel. Today we will be learning about another measure of location that can be used to work out the spread of a dataset, which is the variance. This makes use of the fact that each data point deviates from the mean by the amount x minus x mean, or rather the mean itself, where variance is equals to the summation of x minus mean whole square divided by n, or it can also be written as summation of x squared divided by n minus the mean whole square is equals to Sxx divided by n, which is the summary statistics of x, as given here, where xx is equals to summation of x minus x mean whole square is equals to summation of x squared minus summation of x whole square divided by n. The second version of the formula, summation of x squared divided by n minus summation of x divided by n whole square, is easier to work out with when given raw data. It can be thought of as the mean of the squares minus the square of the mean, and this will help you to remember it. The third version, Sxx by n, is easier to use if you can use your calculator to find Sxx quickly. The units of the variance are the units of the data squared. You can find a related measure of spread that has the same units as the data. Now let's talk about the standard deviation. The standard deviation is the square root of the variance, which exactly has the same formula but with a square root. So sigma is the symbol we use for the standard deviation for a dataset, hence sigma squared is used for the variance. You can also use these versions of the formula for variance and standard deviation for grouped data that is presented in a frequency table, where sigma squared is equals to summation of f multiplied with x minus mean whole square divided by the summation of f, and the standard deviation will be the square root of the given expression, where f is the frequency for each group and summation of f is the total frequency. For number 3, 8 students' heights, h centimeter, are measured. They are as follows: 165, 170, 190, 180, 175, 185, 176, and finally 184. For number A, we have to find out the mean height of the students. So if you remember the formula for mean, which was the summation of x divided by n, where summation of x is the sum of the data and n is the total number of data present. So here summation of x will be 165 plus 170 plus 190 plus 180 plus 175 plus 185 plus 176 plus 184, which is the summation of all the given heights here, and divided by the total number of heights. As you can see, there are 8 here, so we divide this with 8 and we get a value of 178.125 centimeters. And to round this to 3 significant figures, we can say that this is going to be 178 centimeters. This is the mean height. For number B, it's given that summation of h squared is 254307, so we have to work out the variance. If you remember, the formula variance, which is sigma squared, is equals to summation of h squared divided by n minus summation of h divided by n whole square. In this case, we are using h because this is the height in h. You can also use x here, just like I did, to denote the heights, and this gives us 254307 divided by n, which is 8, as there are 8 number of heights here, or 8 students, then divided by the mean square. So we have already found out the value of mean here, so we can just place it here and then square it, and this gives us a value of 59.86 centimeters squared, which is approximately 59.9 centimeters squared to 3 significant figures. For number D, we have to work out the standard deviation. So standard deviation is simply the square of the variance. So standard deviation is equal to this. So root over 59.9, which gives us an approximate value of 7.74 centimeters. And this is our answer. For number 6, In a student group, a record was kept of the number of days of absence each student had over one particular term. The results are shown in a table. So we have numbers of days absent and their corresponding frequency. We have to work out the standard deviation of the number of days present. And if you remember, standard deviation was the square root of the variance, which was summation of x squared divided by n minus summation of x divided by n whole squared. In this case, because there is frequency present, so we have to use the alternative formula for frequency, which is going to be fx squared divided by summation of f minus summation of fx or xf divided by summation of f whole square. So first of all, we have to calculate the values of x squared, then we have to multiply it with f, and then we can apply the formula. So that means we have to tabulate this vertically. So the number of days absent can be said as x, then frequency as f. So we can add the rows here and the columns being 0, 1, 2, 3, 4 for the values of x, and for frequencies they are 12, 20, 10, 7, and 5. Now what we do is we add another column with x squared, which we get 0, 1, 4, 9, and 16. Now we can calculate the value of xf, which is going to be 0, meaning the multiplication or the product of these two. Then we have 1 multiplied with 20, which is 20. Then 2 multiplied with 10, which is also 20. Then we have 21, and then finally 20. And now we find out the product of x squared with f. So simply multiplying these two gives us 0 again. And then 20 with 1 squared gives us 20. 10 multiplied with 4 gives us 40. 7 multiplied with 9 gives us 63. 5 multiplied with 16 gives us 80. So we can now calculate the summation of x squared f or fx squared. The order doesn't really matter. So this is the value of 203. Summation of xf is going to be 81, and summation of f is going to be 54. So now we can apply the formula. Standard deviation is equals to square root of this summation of x squared divided by summation of f. So 203 divided by 54 minus summation of fx divided by summation of f whole square. So this is going to be 81 divided by 54 whole square. And this gives us an approximate value for 1.23 days. For the last question, in number 7, a certain type of machine contained a part that tended to wear out after different amounts of time. The time it took for 50 of the parts to wear out was recorded. The results are shown in a table. So we have a table consisting of lifetime in H which is ranged and continuous, and then we have their corresponding frequencies. So if you notice, the endpoints of the classes overlap. For example, 10, which is the highest boundary of the previous class, overlaps with the lowest boundary of the next class, so we do not have to apply the correction method. The manufacturer makes the following claim: 90% of the parts tested lasted longer than one standard deviation below the mean. Comment on the accuracy of the manufacturer's claim, giving relevant numerical evidence. So first, we have to calculate the standard deviation and the mean as well. Then what we do is, using linear interpolation, we find out at which percent or what percentile does this specific value exist, and then we compare it with the 90% given here. First of all, let us tabulate this vertically. So we have H here being 5 to 10, 10 to 15, 15 to 20, 20 to 25, and then 25 to 30. And we can find out the midpoint x, which is going to be, for 5 to 10, it's going to be 5 plus 10 divided by 2, using the formula for midpoint of AB being equals to A plus B divided by 2. So this gives us 7.5. then 12.5, 17.5, 22.5, and then 27.5. Now what we do is we write down the frequencies of the corresponding x values, which is going to be 5, 14, 23, 6, and 2. We can find out the x squared, which is going to be the midpoint squared. So this is going to be 56.25, then 156.25, similarly 306.25, then 506.25, 756.25, and we have calculated the values of x squared. Now we can add another column, or rather two columns, to include xf as well as x squared f. So here this is going to be 37.5, 175, 402.5, 135, and finally 55. So x squared f are going to be 281.25, then 2187.5, then 7043.75, 3037.5, 1512.5, which we calculate the values from using the calculator. So we can say that the summation of f is going to be 50. Summation of xf is going to be 805. Summation of x squared f is going to be 14062.5. Now we can calculate the mean, being equal to summation of xf divided by summation of f, which is going to be 805 divided by 50, which gives us a value of 16.1 hours. Now we can calculate the standard deviation, which is summation of x squared f, or fx squared, divided by summation of f minus the mean whole square. So xf divided by summation of f whole squared. This gives us 14062.5 minus the mean whole square, so 16.1 whole square, giving us a value of 4.69 hours to three significant figures. Now what we do is we calculate one standard deviation below the mean. So what it means is that it's going to be mean minus one standard deviation, which is 16.1 minus 4.69, and this gives us a value of 11.41 hours. Now we find out where this exactly belongs. If you look at the ranges here, 11.41 lies within 10 to 15 group, because it is greater than 10 and less than 15 hours. So using linear interpolation, first what we do is we draw a straight line like this, and then we place the end boundaries or the class boundaries here. So at the middle is going to be 11.4, at the end is going to be 10, the lowest boundary, and at the rightmost end is going to be 15, the highest class boundary, and their corresponding cumulative frequencies. So we have to add another column to highlight that. So cumulative frequency for the first one is going to be 5, and then it's going to be 5 plus 14, giving us 19, and then this is going to be 23 plus 19, which is going to be 42. And we don't need to continue because we already have the required cumulative frequencies. So for the class boundary of 10, we can see that only 5 of the parts were there, and for the class boundary of 15, only 19 were there. So we didn't even need to calculate 42 here. So this is going to be 19, and this is going to be 5, and we don't know at what percentile or what cumulative frequency does this value take, so we write that as x. So using linear interpolation, x minus 5 divided by 19 minus 5, meaning x, which is the unknown variable, minus the lowest boundary divided by the highest boundary subtracted with the lowest boundary again should be equals to their corresponding values of time or lifetime. So for X, it was 11.41. For 5, it was 10. And for 19, it was 15. Subtracted with 10 again. So if you see, 15 corresponds with 10 here. And 19 corresponds to 15 here. And solving this equation gives us a value of X being 8.95, meaning that there are only 8.95 parts, or the cumulative frequency if you remember, that have a lifetime of 1 standard deviation below the mean. And now let's calculate the number of parts that have a lifetime greater than 1 standard deviation below the mean. So because the total number of parts were 50, so we subtract this with 50, giving us 50 minus 8.95, which should be 41.05 or 41 parts, because in reality parts cannot exist in fractions or decimals. So the percentage is going to be 41 divided by the total number into 100%, and this gives us a value of 82%. But because the manufacturer said that 90% of the parts tested lasted longer than 1 standard deviation above the mean, this means that the claim is false, because as you have seen that this is actually 82% that lasted 1 standard deviation below the mean. So claim is not valid or not accurate. Thank you all for watching. Please make sure to leave a like, comment, share, and subscribe if you enjoyed my content. See you guys in the next video. Goodbye.